climate change. Hydrogen gods of the sun.
Good day, everyone. Today, we're going to put climate change into context. Now, we're going to concentrate on two things: light and heat. They are not the same things. Now, light is generated from the sun by hydrogen, the nuclear reaction that's taking place there. Now, once light hits the earth, it changes into heat. And the heat now supposed to radiate back into the atmosphere, but it doesn't, because even though the light passes through the greenhouse gases, but the heat that is generated cannot do the same. It cannot go back, cannot pass through the greenhouse gases into the atmosphere. So most of the heat is trapped, and that's what results in the increase in temperature on Earth. And this is leading to lots of unusual weather patterns. It leads to floods, it leads to wildfires, it leads to all the things that are related to climate change. Right, unusual weather patterns. For example, areas where used to have like kind of high amount of rainfall. For example, you can have rain that could fall for say a month, can fall in say an hour. Usually, this type of weather patterns might say occur say once in 10 years, but now they've become frequent. You can have them twice in a year or even 4 times in a year. So this unusual weather pattern is the outcome of the planet heating up. So we're going to examine why this is happening. Why does light pass through the greenhouse gases like CO2, nitrous oxide, methane, to name a few, but the heat that is generated cannot go the other way as it's supposed to? Now, if we look at the light ray, for example, I've given the example there of one light ray. I was taking one light ray. We see that the particles, the photons, the smallest light particles called the photon. The photons in the light ray are made up of short waves. The short waves, they have more energy and they could pass through surfaces like glass or greenhouse gases. But the heat waves are long waves, long infrared waves. They don't have sufficient energy to go the other way. Now, when we're talking of waves, there are lots of things have wave-like nature. On the micro scale, electrons have wave-like natures, the same as on the macro level. We'll look at the sea. We'll see the waves there, waves in the sea. When we talk of high tide, the waves are high up and they are close together, and they have more energy because they can destroy coastlines. So we say short waves. Short waves have more energy than long waves. The sea, when you see the sea waves, when it's low tide, the waves that come ashore, their frequency is longer, and they're long waves. Yes, they're all the same things, right? Micro level or in macro level. So this is what climate change is all about. We can also see waves in the radio waves. We have shortwave radio, which I used to listen to many years ago. It's now changed to digital radio. Shortwave radio You could broadcast from different continents and you listen to other continents. Whereas long wave is mostly the surface radio, less energy. So we'll put this into context. So I'm going to ask young lady, do you understand the difference between light and heat? So
Yes.
okay. What is light and what does light do? Where does it come from?
Okay, so light comes from hydrogen, as we should know, and heat comes from the sun.
No, you get that wrong. The hydrogen is what generates light from the sun.
Hydrogen generates heat to the sun.
Light generates light from the sun. Okay, and then the light goes now. When it strikes the planet, it converts into heat. Okay, and the heat now cannot escape. So, can you give us an example where light can pass through the window, for example, the car window, and then heats up, but the heat cannot go the other way? Have you experienced that before? That when light comes through the car window,
or when they're in a house.
Or in the house, yes. But the heat that is generated cannot go the other way. Have you experienced that before?
Yes, because the light can come through and the heat, but it won't be able to go back out unless you open your car window or the window inside your house.
That's right, yes. So those are all, that's what we call greenhouse effect. So can you name some of those greenhouse gases there?
Okay, so the first one, CO2, is carbon dioxide.
Okay,
the second one, N2O, is nitrous oxide.
Good. Yes.
And then the third one, which is CH4, is methane.
That's good, yes.
And there's also ... because there are other greenhouse gases.
Yes, you can see them on that map there. You can see all the other greenhouse gases.
These are all the greenhouse gases.
Yes, there's no need including those there because these ones are the ones that humans produce. So you have things like water vapor, which is not produced by humans, but yeah, it's there in the atmosphere. It's a greenhouse gas as well. Yes, like ozone and the hydrofluorocarbons. So yes, this is about the climate argument. So they can also use light as a metaphor. Okay, metaphor means if someone said it was a heated argument, it means the argument was not good, it lead to something else. Right? Or if you say someone brought light to an argument, that would mean the person brought understanding to the argument. So light and heat can be used as metaphor, where light is good and heat is not good. So that's where we're going to end this today. And then you want to ask a question?
Well, I want to say something actually. If you don't know what a metaphor is actually when you say something that is not real or not true. So yes, you can actually use the light and heat of the sun as a metaphor.
Oh, thank you very much for that. Okay, we're going to end it there, and you have a blessed day, everyone. Okay.
Subscribe to Day African Teacher on all platforms.